All right. So, like I was saying, the components of GIS are about 5 of them, and they are easy to remember. Really, the it's the computer. Everything up to here is like the computer, hardware, software, data. That's really computer. Okay, that's what computer. The hard bits that you can touch in the computer, the hardware. The software is what you cannot touch, but which people have made a lot of money from. Okay, because that's where the instructions are. And people are the people, they destroy everything. Africa, we have the hardware, software, we have data. If we have everything, the people are the problem in Africa. Are you with me? I will say this, it's not politics I'm doing here. This is the truth. So people play an important role. You can go and buy a big computer, very high, i7, and then someone will just mess everything up for you. The system won't work. Okay, so the part of GIS go beyond the methods. Really, you can't have a GIS which doesn't relate to a particular area, a particular domain. Okay, you can't have a GIS which doesn't relate to a particular domain. There should be a problem area where you're trying to actually solve a problem. Okay, so ECG will introduce GIS, and then why would they introduce? Because they want to know which lights are off, who is owing, and where they are, and that is why there's a lot of projects on ECG surveying work is going on. People are, let me just say, people are cashing in, because ECG has realized that they need to know where their customers are. And all these years since Kwame Nkrumah, we never knew where their customers were. Truly, people came in to take, read the meters, but they didn't have a clue where they were. Are you okay, for real? And even their poles, they didn't know where they were. You see, people, the poles are there, but the managers probably don't know that the poles are there. If it's bent, they wouldn't even know. Okay, so that is what GIS is coming for. It's coming to now put the methods, bring people, experts, users, put them on a computer. Okay, can we talk about computer network? And then we can share data. Okay, we have web programs, web applications like WebGIS, like Google Map allows you to find the shortest distance, the optimal routes. Okay, for those who don't know what hardware is physical, the physical parts of a computer. Okay, when we talk about computer, we are not talking about your laptop. We are not talking about the desktop. A computer can be your phone. It's a computer. So when you go to computer science department, they teach about phones, how phones work and all that. I don't think computer is just, in fact, the smartphones we are using, they're actually computers, and they have OS, they have operating system, you can install, you can update. All those things are things that you do on a computer. All right, now something like an aeroplane can have a computer in it. The autopilot is a computer. So you understand that. So the parts that you can touch, okay, monitor is an example, keyboard is an example, okay, etc. Please, when I move fast and you don't get something, you ask a question, I'll be happy to stop and then explain it. CPU, central processing unit, okay, which means that a unit is always made up of several items. So you can talk about the RAM, which is the random access memory. So anytime you start your computer, the computer needs to remember certain things that are happening right there and then. So it keeps that in memory. So the RAM is temporary storage, whilst the hard drive is the permanent storage. So when we talk about storage, we're talking about permanent storage. When we talk about RAM, that's temporary storage. All right. Now we have what we call the motherboard, which actually houses the processors. Okay, there's something we call the BIOS, which I'm not here to talk about that, but you need to know some basics about a computer hardware. A good CPU is required for most GIS because GIS, there's a lot of data you need to keep. Remember that if you are doing a GIS for forestry, then you got all the trees to keep. All right, so it's a lot of data, huge amount of data. And geographical data is not your normal data. It's not like 1, 2, X, like text and the numbers. Are you okay? Geographical data also contains X and Y. Remember that, because the X and Y, that tells you where, or the longitude and latitude, that tells you where the things are, where the objects are. All right. Also remember that we need to improve on query time. So you need a good computer, a good CPU at that. A good computer is one that has a good CPU. All right. Now, one of the hardware of a computer, not really of a computer, but hardware in GIS is what we call the digitizer. Are you okay? So the digitizer is what you see this woman sitting in front of. Are you okay? A digitizer board is a flat board used for vectorization of any hard copy map. What is vectorization? It's digitization. Digitization. Are you okay? That gives you just coordinates. So in other words, she's clicking on an object that she's seen on that map. Okay. And then as she clicks it, that data is converted into a digital form, normally coordinates. So once we are vectorizing, we are actually creating points, coordinates. Are you okay? Point coordinates. All right. So we create what? A vector data. We can make points. Points can be used to make lines, and the lines can be used to make polygons. Later, we find out that this is the so-called vector data model. Is that all right? So the digitizer is a very important tool in GIS. So let's talk a little bit more about digitizing. We can have three modes of digitizing. Okay, we can have the point mode, or we can have the stream mode. So you can imagine that the stream mode is an automated mode, whilst the point mode, you pick the points that defines the shape or the geomorphology of the object of interest. So if you want to say digitize a river, which you see on a map, so normally you have a hard copy map that you want to digitize. Are you okay? All right. And then at the end of digitizing, you get a vector, you get XY coordinates. Are you with me? Great. So you can choose the points yourself. That's point mode. Or you can go into stream mode, which is automated. So you just hold the mouse. So like I said in the previous page, you can see the woman is actually holding some kind of thing and she's moving it on top of it. You can just hold it, move it around, and as you move it, you tell the computer that it should be collecting its own data. So the mouse that you are moving around is more or less clicking, you are clicking with it, and then the computer is recording the coordinates of those points. Is that okay? All right. So let's say if you click here, then it gets the coordinates. If you click here, it gets a coordinate. But why are you clicking these locations? Because you know that there's something going along that you want to capture. Are you okay? So the object could be anything, could be a railway or something like that. So what I want to do is that I want to just keep picking points along it and enjoying the map. So this is how digitizing is done. Are you okay? This, what I'm doing now is point mode. If I'm in stream mode, I'll just hold it and move it. I won't click, but the computer itself will be doing the clicking for me. That is stream mode. Then we have the on-screen digitizing. In on-screen digitizing, like what I've just done, I'm actually digitizing on-screen. I'm not using a hard copy. So in on-screen digitizing, we make use of, scanned map, a map that has already been scanned into the computer. Are you okay? You don't take a hard copy and then you mount it onto a board, and then you connect the board to a computer. I hope you can imagine, you need a little bit of imagination there. Okay, so I think we'll do a practical on this. So take the theory as it is, hoping and knowing that when we do the practical, you can unite this theory with the practical. All right. So when you actually digitize, there are errors that arise. So here we are having a line that was supposed to reach this line, which is not. Okay, so this line is supposed to go all the way and reach that, but it's not. This line was supposed to end here, but it's gone farther than that. Okay, so we need to cut it. So we have an overshoot. Here we have an undershoot. The undershoot needs to be snapped to it, or if you like, extended. In AutoCAD, we call it extend. And then in GIS, we just say we're snapping it, but really it's an extension that we are doing of the line. All right, so these errors need to be corrected for. There are also topological errors. Very soon we find out what topology is. Okay, all right, so there you go. These are errors that arise. Okay, when you are digitizing, get to know the purpose. Okay, what am I doing the digitizing for? All right, what coordinate system? So later we'll find out that there are different coordinate systems. So you need to know. All right, what is the accuracy of the layers that you are working with? So if it's for an engineering project, you are in trouble. Maybe 3 millimeters accuracy. You need to really, take note of the accuracies. What is the accuracy of the map being? Okay, then again, accuracy comes in. When you digitize, don't digitize more. Let me go and eat some wachi. I'll come back and continue. Digitize some fufu here. Digitize, go and sing a song and come back. Don't do that. This will make your technique more consistent. If you just digitize as much as you can, then you have some consistency. Okay, because you usually have, some kind of picture, okay, as you are seeing down here, and then you are trying to click along it. So in your mind, maybe the way you were thinking that a building should look like, it's not how it's looking like. After eating the fufu, now you are in a good mood and you are seeing things differently. Are you okay? So you make sure you digitize as much as you can. For more consistently, only one person should work in a digitizing project. One person digitize, it goes. Kojo Mensa comes and continue. Peter comes and does it. Are you okay? Abenyaga also tries it. Are you okay? Etc. Yeah. Alasan also takes it and then does it. By the time we are done, what you are thinking is a road is looking like something else, like a gully. Are you with me? All right. Let's take note of that. And then, of course, you need to select common reference points. Okay, that connects different sheets. Sometimes you are digitizing different set of sheets. Okay, so that is what we are talking about. Okay, great. Otherwise, you have problems. You know how you have a mismatch. You can also digitize and collect attributes at the same time. What are attributes? The attributes are, for example, you are digitizing a river and you know that the name of the river is River and Cobra. Okay, you need to collect that as well so that you don't go back again whilst you finish the digitizing. Okay, someone go and tell us what the names of those things are digitized are. You need to include attributes as you go. If you can, it will save you time later. That's what he's talking about. Okay, will it be merged with a larger database? Like we said, all these things point to a database. Okay, when you're doing all these kind of things, you are heading towards a database. So you need to know to help you. Okay, one of the other hardware of GIS, so we just finished talking about the digitizer. We can talk about the scanner. So the scanner and the digitizer, what's the difference? The digitizer will give you coordinates. The scanner will give you pictures. So everybody has seen a digitizer before at the workplace. You just take a paper, you put it inside the scanner, and then you press a button, and then you have the digitizing done. Okay. I'll be asking you a question. I've seen that most of you are not visible. So to check that you are listening to me, I'll be asking a question very soon.
So we are listening.
No, it's fine. No, it's fine. But I'm just telling you. I want you to know.
Okay. Okay.
If people are having ideas. Yeah. Great.
So
it's the first time we are doing this online thing. So we have to put our feet on the ground so that it works. Okay, great. So here we have a scanner and then it's scanning A3. We can use the scanner to scan A2. Okay. Use the scanner to actually scan, A1. You can, different sheets of paper. I think this is supposed to be an animation. So that's why you see a repetition of the diagram, the picture. All right, great. We have, so what we get is a pixels. When you scan a picture, a hard copy picture, what you get is pixels. Pixels stand for picture elements. Pixels stand for picture elements. All right, great. Another hardware component is what we call the plotter. So the plotter is a printer, a large format printer. Format is size. I'm not named for dimension, size of something. It says format. So a plotter is a printer that prints a larger format of paper. Okay, so you can print really. In fact, getting even an A3 printer is not easy. Have you realized that? Okay, so the plotter is really good for printing huge size of paper. You can see the size of this paper. AO is about 1,000 millimeters. 1,000 millimeters is 1 meter. That's really huge, isn't it? Yeah, 1 meter. Meter paper is big. Yeah. Okay. All right. So GIS software. Remember that every software has to have certain attributes and characteristics that are desirable. One, every software should be able to generate data, store data, help us to store data, analyze data. We need it for manipulation and to display data. So it needs to be user-friendly. It needs to have functionality. It needs to be compatible. It needs to be updatable. It needs to have documentation. and it should be cost effective. Okay, user friendliness means that I should be able to use the software without much intervention. Are you okay? Sometimes if you are struggling to know how to use the software, then of course it's not good. Functionalities means that I should have the things you want to do. Maybe you want the software to tell you, okay, if I have this location, tell me, all points that are 2 kilometers away from this point, and the software cannot do it. It doesn't have that functionality. So it should have functionalities. All right. It should be compatible. Some software run on one system, they may not run on another system. Updatability, even WhatsApp gets updated, doesn't it? Even WhatsApp that we use for, gossiping and all that. No, I mean, I'm just saying it just to make the class lively. But WhatsApp is a very good tool, okay, for projects and all that. But it even gets updated. WhatsApp gets updated. Okay, so it's very important for us to have a software that will update, that will get better and better. Okay. All right. It should have documentation. If there's a problem in the software, we should be able to go and read why we can't do certain things in the software. Or you can't be calling the person who created the software. Oh, hello, Mr. Peter. Are you the one that created the software? We want to find out why is it not working. Go and look at the documentation and you'll be fine. It should be cost effective. That means that you don't bring software into an organization and that nothing has changed. You're not the turnover. You're not making extra profits. Then why did you bring the software for? So we need to know that. Example of GIS software, if there are so many of them, but one of them is the ArcGIS, Mapinfo. We have that we even have ArcGIS online, which means that a web application version of software these days. Mapinfo is used in mining sites. They have an extension called Discover that allows them to look at the whole, all in 3 dimensions. So a lot of geologists like Mapinfo because of that extension. Australians developed that extension of Mapinfo. I don't know if they developed the Mapinfo, but it's very good for miners. I've seen them use it, so I'm talking from experience. Is that okay? All right. It's very important for us to look at data. We finished looking at software. Are you okay? I mean, that's all we can say. Software is really a set of instructions, the programs that run on the computer. That's it. Are you okay? But then it's very important for us to also look at the data. That data is very important in GIS. Is that okay? Geographical data, related tabular data can be collected in-house. Remember that geographic data is usually separated from the attribute data. Is that okay? So normally people talk about geographic data or spatial data, and then they will talk about attribute data. Geographic data more or less has the locational bits, XY. The attribute data will tell you maybe how deep that location is. Is that okay? So if at the point XY, 6 meter deep, if you are 6 meters deep, then 6 meters become the attribute value at XY. Are you okay? And then maybe there's more we can write. Where is this place where we have measured 6 meters deep? We can see the town where it was measured. We can look at the soil type there. We can look at IOK, the district. So there are 1,001 information that we can actually find at one particular location. IOK. So where I am now, my location here, there are a lot of attributes that can be associated with it. IOK, temperature is one of them. You can look at humidity where I am. You can look at what town I'm in. Are you with me? You can look at the kind of geology IOK that characterize where I am. Okay, so we can have geographic data. We can look at attribute data. So when we look at data, always look at the 2 aspects of it. Is that okay? All right. We can collect this data. It's very important for you to take note of that. We can collect data ourselves. Okay, so attribute data is what I'm talking about. Okay, great. Now, when you talk about data, when you collect data, data can be placed in different scales. Okay, so we can collect data that is just names of places. So we can just collect. Okay, this place is called Kumasi. This place is called Accra. This place is called Tamale. Are you okay? That data, such data, we call it the nominal data. All right. Then we can also have ordinal data, which is data about, classes of data. In other words, when you have road class A, road class B, soil type B, soil type B. When the data is categorized and classified, we can call such data ordinal data. Then we can also have what we call the interval data. Data with the interval makes sense. Okay, but the interval may make sense, but then it may not have an absolute zero. When the data has an absolute zero, we call it ratio data. Is that okay? So I will give an example. Temperature is interval data. The intervals make sense, but remember that minus 20 degrees Celsius exists in Russia. And in Moscow, when you say minus 20 degrees Celsius, maybe everybody's excited. Why? Because the temperature can go to minus 30 degrees Celsius, where you are really frozen, isn't it? So in that case, what is zero? Zero is hot. And zero is not just nothing. Zero is something in Russia in terms of temperature. So the ratio data is any data you collect in which there is an absolute zero. Meanwhile, interval data doesn't have necessarily an absolute word, zero. All right, so the question to the class, you can unmute your mics and then contribute to it. What do you think the stock exchange values are? Why I ask this question, because I like watching CNN and you see the stock indices running under it on TV. Is all right. So if you see values like this, what would you say they are? Are these nominal, ordinal, ratio, or interval data? You can unmute your mic and then say what it is.
Sir, they are interval data.
Why? Always explain. Always explain. If you don't explain, your answer can always be yes. Go ahead. Go ahead. I'm listening to you.
Say because the stock the point the point we have point 0.2 24
yes
and 1.01. So that's why it I said it's interval.
It's because the intervals make sense. The intervals make sense. So that if the points go up, it means the company is doing well. When you look at stock, when you talk about stock, you're talking about company, isn't it?
Yes, sir.
Yes. So that is the reason. The reason is that the intervals make sense. It means that between minus 0.2.24,
yes,
a company even with 0 points probably is better off than 0 points, the minus one. Okay. What about Kojo Thompson Road? Thomas, what do you think Kojo Thompson Road is? Is it ratio? Is it interval or ordinal?
Yeah.
That one is what? Yeah, you have to just say it and get it wrong, so that you don't go and get it wrong in the exams. So,
yes, sir.
If we do online exam, it's even difficult than sitting down and writing. Yeah, what do you think? If someone went and collected street names like Kojo Thompson Road, Adwamansa Street, and these things, yeah. Westland Boulevard. There's a road in Medina called Westland Boulevard. I like the name. It sounds more like American something, isn't it? But what do you think such data is? Is it ratio data, ordinal, interval, or nominal?
So it's ordinal.
It's what? Ordinal. I think you are trying your hands at the national lotteries, isn't it? The numbers are. I remember in the 90s or something. Yeah, you hear, and the numbers are.
Yes, sir.
24. That is what you are doing. Yes. Okay. The reason why it's not ordinal is because you see the nominal data is data about names. Nom in French, when someone say nom, he's saying name. So in other words, you check out if the data is a name, then it's nominal. If the data is
Oh, okay.
class, if there's a class in there, because remember that the street names are not classed, they are not classified. If someone gives you a street name, it doesn't mean anything. It doesn't mean the people there are rich. Are you okay? You can even have a street name that sounds very nice, but the area is very, very like poor. They don't have money. Are you okay? They are the affluent people that don't live there. Are you with me? So the names are just names. Okay, names are just names. Like someone said, what is in the name? But some names are powerful anyway. So let's not go there. All right. So that is that. I hope you've learned something from that. People, like I said, are very important. Okay. So when you look at GIS in this picture, you can see that people make the thing work. The objects, the software, the hardware, they don't mean anything. Okay. So here we have written approaches, but what we really mean here is what? Methods. Are you okay? So this methods. This is a diagram that I picked off. I just put it in methods. So software, data, methods, people, hardware. Okay, there you go. And people. I okay, the brainware, so-called brainware. So if you get someone who is really an expert, all of a sudden the ArcGIS you've installed in your company will now begin to look like you are benefiting from it. Otherwise, it should just be sitting down like that. Nothing will happen. Of course, we need to consider the users as well. Of course, the methods, like I said, need to look at every business and company has some kind of business rule or something, a way that they do their things. Are you okay? I can always use the exploration because I work with an exploration company. And what they do is they go out first to go and pick soil samples. This is how they get to know if there's a gold. Go and pick soil samples. They take it to the lab. But the soil samples, they first kind of grade the area so that they can pick it in a certain fashion. Okay, so the whole place is graded, and the grade intersections, they pick the soil samples at a certain distance. So they dig a bit and pick it. Then based on that, they drill. So you see, there's a method. You see that? Okay. So every GIS, you make sure that it integrates that business rule, that this is what we do as an exploration company. Exploration companies are not mining companies. Remember that. So every company has what they do. This is what I do. Okay, I shine shoes, but how do I shine the shoes? I actually move to affluent areas, East Legon. That's where I shine my shoes. That is a business rule. Okay. So we need to understand that GIS should incorporate it. Okay, it has to operate according to a certain plan. You can't bring a GIS and it's doing its own thing. The company is also doing its own thing. When you look at KFC, they were picking the properties where they are selling their fried chicken on purpose. Okay, more or less the interest. I read in a book that the interest was more in the real estate than even the chicken that they were selling. So you wouldn't know, right? Would you? You think you are eating chicken. You don't know. Someone is up to something. Are you with me? All right. So basically, this is where we are with it. Who can tell us how many minutes we have to finish this session so that I decide on what I'll do? Okay, we have 10 minutes. In fact, I was just told we have 10 minutes. Okay. Are we all happy?
Yes,
with
sir.
what we talked about so far?
Yes, sir.
Yeah.
Hello.
Yes, sir.
Hello, sir.
Yes.
Hello.
Yes.
I wanted to ask a question.
Please go ahead.
Did mention you did mention about the soil investigation. I heard something like you drill and then you get the sample from the soil.
Yes.
I wanted to find out for that investigation, the sample that they are taking, do they have a certain depth that they have to go, or they did it based on what they are looking for, or they just dig it anyhow? I just want to know how to a certain depth,
Yes.
what
So,
exactly
yes,
did they go?
I think I like your question because questions like this really help us to throw more light on what we're talking about. Yes. The topic or what I was talking about is the method. GIS has 5 methods, and one of the methods is the methods. Okay. And under methods, we are saying here that a successful GIS operates according to a well-designed implementation plan and business rules. And I was saying that for every business, there are what we call business rules, which really define the business. So what do we do? Okay. Now I was using the mining area, the mineral area. Those who go for minerals, take for gold, take for diamonds, as an example, because I've worked there before for a while. And for exploration, exploration is different from the actual mining. Okay. That means that the mining means they are taking it, which means that they know what is there. But exploration is discovering what is there. Now, where did I learn all this from? I learned it from the geologist. So I've actually gone to learn the business rule of a company. Are you okay? And now I think you are now interested in how it is done. Are you okay? But to get even further details, how much deep they go in picking a soil sample, we will need to get to a geologist and then find out further how deep they dig. Are you with me?
Okay, sir.
This is the business rule. Are you with me? So
yes, sir.
In GIS, when you apply GIS to any business, any area of interest, you first have to understand their business rule. Then you now operate the GIS according to a well-designed implementation plan and the business rule. So you have to implement the GIS and then make sure that it works tightly with what the business rule. That this is what we do. So otherwise, so what it means is that you can learn the GIS, but when you reach the company, you look totally strange. You wouldn't know what to do at all because you don't understand what they do. You have to probably stay with them a bit and understand the business rule. Then you now start implementing. So the question that you've asked, how deep I wouldn't know because I'm not a geologist. I've just learned a bit about it. But what we can do is that, so in every particular question, say in forestry, for example. So now let's move away from mining. Let's go to forestry. We may want to find out where should we cut trees? So we know we have to cut trees, right? But you just can't cut any tree.
Yes, sir.
So now the business rule now for forestry, it will be, okay, we encourage, the felling of trees, but we don't just allow you to cut from anywhere. That is that's where forestry comes in. And that's why forestry exists. And so now how will the GIS now come in? They will have to tell you, those who have gone to learn about the resource, are you okay? Forestry and resource, they have a name they call it. Are you okay? Natural resource, exactly. Learn about natural resource will tell you that you shouldn't be cutting this tree because it's an endangered species. Are you okay? Etc. And then this particular tree is always a certain distance from these other trees. So now the GIS now takes that information and start implementing it. So now the software will now go get the data and then now start telling you. So you can't cut from here. Meanwhile, you can't use your own brain to quickly tell where we shouldn't be cutting from. I don't know if what I'm saying makes a little sense. I don't. Does it?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay, that's good to know. That's good to know. So you need to look at a particular, for example, ECG and all this. If you move away from, we've just moved from mining to forestry, natural resource. We can come to ECG, for example. You realize that they have low voltage poles, high voltage poles. Okay, so you need to learn that, because if you don't, how would you understand what I'm saying? They can reveal a lot of things to you that you never know. But every day you have a light pole standing in front of your house and you don't even have an idea that that's what's happening. I was told that they lose a lot of, the power. There's a lot of power loss. If they didn't tell you, would you know? You wouldn't know. So maybe the goal of a new company into power and energy sector will be to say, okay, we minimize on any power loss and things like that. And then your GIS now has to pick that. They will tell you, they give you the business rule, and then you now integrate it and you work with it. So under methods, I want you to understand that most of the questions that you'll be asked in GIS will always look at methods. First, it will introduce you to the methods. Then you will have to see how you use GIS concepts. You know, so that is why I think our next topic will be touching on the concepts of GIS. So let's get ready for it. And I believe we're meeting next week, same time. And yeah, please download that software. At least you download it. Don't use it. Just download it, put it now.
Okay.
In the appropriate time, we get used to it. I don't know how we're gonna do this, but the semester is far, you know, advanced. Are you aware that we are somewhere in the middle of the semester?
Yes, sir.
So what happened? How come you are now coming? Okay, I'll discuss with the class rep. I'll probably discuss with the class rep. And